Swayam Prabha. Digital India. Educated India.
Welcome all. I am Sachin. Right now I am going to explain the principle and the circuit what goes in a potentiostat. So in this demo, I will first take you through what is inside the potentiostat. Then we will move ahead with the how we try to build a potentiostat in 2000 rupees with this and how the data compares with what we got there. So it will not be much, but yeah, we will try to see. So why we need a portable potentiostats? Because nowadays everything is going portable, and you can even using this potentiostat, what you can do is sensing at your home. You can do the corrosion sensing at your home. You can do a fruit sensing at your home, whether how much pesticides it contains, how much herbicide it contains, and rest other things also. So how things go is I will first take you this point. So when we do electrochemical study, corrosion happens, we simulate in our lab. We simulate on a potentiostat, and we then tell this material can work this much time. How that happens, what goes inside that? So what goes inside that is the operational amplifier connected with the ADAC and DAC, analog to digital converter, digital to analog converter. Here I am showing you the main circuit where potential to current or current to potential happens. Now, before going ahead with that, I would like you to look at the operational amplifier. So what is the operational amplifiers? Basic electronics, anybody? No. So amplifier does the amplification. It's thus either it will in the forward or backward direction. So what we are doing is here is the operational amplifiers. What operational amplifiers does? It does a amplification either with the subtraction, addition, multiplication, and integration. It will not do division part. Okay. So there will be two things. Here you can see there is a 2 input, 1 output. Operational op amp will have a 2 input and 1 output. Now, you know op amp, what will happen? So when you do a potential scan in the potentiostat from certain value from minus 1.5, let's do to 1. The potentiostat has applied you minus 1.5 volt. This minus 1.5 volt start from the potentiostatic set point will go to the non-inverting input. This non-inverting input will apply that to the V0. There will be certain output from this operational amplifier. This V0 or V out will go to the counter electrode. When the counter electrode, the potential enters, due to the solution bulk resistance, there will be certain change in the current in the electrolyte. This change will be observed over the working electrode. Now you see the working electrode has two things. One is work sense, another is work drive. So whenever you use a potentiostat, there will be 4 wires, almost 4 wires. There will be one counter, working, reference, and there will be work sense and work drive in the working electrode. Now, what work sense does and working drive will do? Working drive will give you your current values. Whatever the current or whatever the potential changes are happening through the current to voltage converter. Now, what does work sense does? What work sense does? When you told the potentiostat to apply minus 1.5 volt, it entered here, it applied certain output. Whether this output is proper or not, how it will know? Then there is a feedback loop you can see here. What does the feedback loop do? Feedback loop will check whether Vi and V feedback are equal or not. If the Vi and V feedback are not equal, then what it will do? It will change the V0 value in such a way that Vi and V feedback should be proper. If it is above or below, then it can increase or decrease in that fashion. Now, this full circuit of measurement with respect to reference electrode is an electrometer circuit. So it will check the potential applied on the working electrode with respect to reference electrode. It will be measured over the electrometer. It will send back to the operational amplifier. Operational amplifier will check whether this both are equal. If not, it will change the value of V0. Because it's amplifier, it will do increase and decrease in such a way that the feedback should be equal to Vi. Now, this is the basic circuit inside your potentiostat, coupled with other noise filters, analog to digital converter, digital to analog converter. That will cost you 20 lakh rupees. Now, so what we try to do, we do a sensing work in other application, and we wanted to show how that can be implemented with the 2000 rupees using a breadboard and some jumper wires and operational amplifiers. So this circuit is inspired from Gabriel and Manoli's work. He used this for a sensing application. Now, what we are doing here, you can see in a potential when we apply in certain fashion. We apply either linear fashion. So how the linear fashion will come? There is a potentiostat, it involves 20 lakh rupees. So there is a Arduino board. There is a Arduino board here. This Arduino board is a Arduino Uno. It has a limitation. It will apply 0 to 5 volt. What it will do from 0 to 5 volt you are applying, it will apply in a certain fashion. So it's a pulse width modulation will be there. It will apply in like square wave form. Okay. Now, it applies in a square wave form, but while you do the measurement, you need it in a linear fashion. Whether you do linear sweep voltammetry or cyclic voltammetry. So how that happens? For that to happen, what we do, this pulse width modulation is coupled with the RC filter here. You see it's a 10 kilo ohm and a 470 nanofarad. This part is there. When you remove this part and this part, this is a RC filter. So what is this is actually a low pass RC filter. So there, when you say a low pass RC filter, it will have a certain cutoff frequency above which it will not allow to go from it. So it will always apply the low frequency, low pass RC filter will apply. Now, when you apply a potential, you need in a certain way, because this is a DC measurement we are doing right now. So it should be a straight. It's not a sinusoidal or width. So RC filter will do, whatever the pulse width that is coming up, it will convert it into a straight line. Okay. Now, the straight line conversion has happened. This part involves the Arduino. From Arduino, you will get a signal that will be in a ramp function like this. Now, before entering this, I will tell you that this full circuit has been divided into 3 parts. It is a voltage summing amplifier part. Another is a electrochemical cell. This is a transimpedance amplifier. It is a transimpedance amplifier. What is happening here? When the potential is coming from here, this will enter to there are operational amplifiers as a non-inverting input. Another is inverting input. It will enter into the inverting input of it. And now you see this circuit that you are seeing is actually called the follower amplifier. So what happens to the follower amplifier is, when you short the non-inverting input to the output of a operational amplifier, it does not give, whatever is the input will be the output, will come as a V in. Now, this part is a summing amplifier part. It will apply a potential divided by resistance. It's a follower amplifier. Whatever is the input will be directly output of it. Now, we have output. What we want to do is V in is there. There is a 510 volt. Now, it's a negative regulator, negative voltage regulator. Why I am using a minus 5 volt? So I have a feedback kind of stuff involved here. This is a minus 5 volt divided by 1 kilo ohm. It will give a certain current. That's why I used a high ohm resistor here, not here. Whatever is coming from it will give a 5, let's just say it gave the input of minus 1.5. Minus 1.5 came here, divided by 510. Then there is a minus 5 divided by 1 kilo ohm. It will be the input at this point. Now, when we say operational amplifier, it's a high impedance thing. When I say high impedance thing, it means it will never allow a current inside it. So whatever is the current, it has to go to the outer loop of the circuit, or it will not enter, it will not go anywhere. So current coming from these 2 points will enter in this, and it will move through 200 ohm circuit. Now, you will say, why you use the 100 nanofarad facility capacitor? This is also a kind of RC filter only. But here, while I am doing the calculation, I am removing the 100 nanofarad part because I am using it for stability purpose of this circuit, of this RC filter. Now, whatever current was coming from here, it entered 200 ohm resistor. It will come out as a V0. This V0 will be directly applied to the inverting input of this electrochemical cell amplifier. Now, when the positive has reached, what you see here is that you see there is another connection from reference electrode. So whenever we do 3 electrode measurement, the working electrode potential will be measured with respect to reference electrode. That I have to implement here. That implementation has happened by taking one reference electrode, this connection with the jumper wire to the inverting input. Now, when I told operational amplifier, we know that the operational amplifier, it will be the gain with the difference of the potential that is coming here. So the potential final will be applied here is a working electrode. Now the application, the potential has been applied on the working electrode. When the potential was applied on the working electrode, there will be certain changes involved in the electrolyte after the application. Due to those changes, when it enters the current will enter from the counter electrode. This counter electrode will go into the transimpedance amplifier. This full circuit is called transimpedance amplifier. This part. What does a transimpedance amplifier does? Transimpedance amplifier converts the current to the potential, because Arduino will never permit current. Arduino board does not have an input as a current and it will not apply the negative potential. Now, when the current is coming, again I have to do the addition part of it. So I can check whether the feedback loop is there or not. Minus 5 volt divided by 24 kilo ohm resistor, you apply, and again, this is again the same as a RC filter circuit. This current entered. Op-amp will not allow the current to pass through it. So what will happen? The current will go from the top part of the circuit. The current entered 12 kilo ohm. Whatever is the value coming from here, it will come from this part. It got converted into potential because we need potential at the Arduino board. Now, when this has come, again it is followed by a follower amplifier. Follower amplifier, whatever is the input, whatever is the output. You will say why you are using it. You could have directly connected with this Arduino board. I am using it so my Arduino board does not get harmed. Now, you see his circuit, it's a Zener diode. If you want to bias the circuit in certain direction, so the current flows in this direction or that direction, you can use this part. I have not used that part. I have not used any Zener diode circuit. Now, this full will enter to the Arduino board. So, you can see here from the digital part, I have taken an input. It goes to the RC filter here, and there is the analog that is directly coming from the 5th amplifier. Okay. Once this part is done, what I will show you is, while I am using Arduino, we can code our values in it. So, for that purpose, what I have done is, you see at this point, I have written an Arduino code script. You can come closer, I think. Arduino code script. Arduino code script, where you can see those values. I have applied the certain change of 100, 20, 100, scan rate also I have changed. Now, and for writing the script, I have written the full part, how the value will change. Okay. Now, well, I will run this. I am just going to upload this on the Arduino board. It has been uploaded. Now I will run a monitor before applying the load with my electrochemical cell. So I am tool, serial plotter. You just check the values that is coming. Current is at certain random value is coming. Doesn't make sense. You see at this potential, this is the potential application. So when the potential application is happening, Arduino will apply 0 to 5 volt. It will not apply minus 5. So how I am getting minus 5? We will convert that 0 to 5 to minus 5 through a formula. So when it is applying a 0, it is applying a minus 1.5. When it is reaching a 256, it reached 1.5. When it will come back again, from that 1.5, it came back again to minus 1.5. This happened at a 100 scan rate thing. Now, after this, you will see the scan rate has changed. So once the loop finishes, it will give you the value. Okay. Now, I will connect the circuit. and then we will see how the changes come. Okay. Now the load has been connected. No one should touch this part. It will be hot because it's a negative voltage regulator. It will convert 12 volt to minus 5 volt. So that will be a kilojoule of energy right now releasing. So what I will do after the connection has been done, I will again upload the code. We can use the same code also, but I will do the fresh re-uploadation of the code. Now if this time I open my serial plotter, you don't see the current value coming at this point. Current value will stay at this point, and you will see certain fluctuations at certain points. So how that will happen and what it will give, I will show you with this fluctuations that you are seeing at certain potential. So how that changes, when you are running this circuit, you can get a serial, this gives you a significance that certain electrochemical reactions are occurring with your system, but what is happening, that we actually don't know. So for that, what we will do, we will use the serial monitor to see how the data is behaving. All the 4 values are coming with the serial number, scan rate, what is being used, and what is the final A0 value that you are getting. You can convert this in a text file and get the data, and after this has been run, this will give you this circuit. Ideally, I was expecting a redox potential. So, okay, this electrochemical cell is a ferriferro response that with the sir I worked on a we work on a catalyst application. So you will drop cast your material on the GC. Before that, what we do the cleaning process and the correction happen. Using the Nernst equation, we know when the redox reaction occurs, the difference between the oxidation and reduction part will be less than 60 volt. But on a practical application, if it's 100, we consider it good for our application. So I was expecting a redox, so a duck-shaped curve. This part it happened at the potential, but the lower part it didn't happen. So we got this value from this circuit. Okay.